Okay, so the purpose of this recording is to provide some additional hints, maybe in a visual way, for page 110, number 34 and 35. So we've talked about this a little bit in class, but I wanted to help you guys set the problem up, because I think once you have that, you guys can actually go ahead and solve it. So for number 34, it says a shell is fired from the ground with an initial speed of 1.70 times 10 to the third meters per second, which is approximately 5 times the speed of sound, at an initial angle of 55.0 degrees to the horizontal. Neglecting air resistance, find A, the shell's horizontal range. So I'm just going to focus on part A because of the fact that you don't want to try to bog yourself down reading a problem and saying, whoa, they're asking me 2 things, I don't know what to do, blah, blah, blah. Just focus on one. So focus on part A first. So I'm going to get a diagram going, fired from the ground. So draw something that's going to be your ground. And it has an initial speed of 1.70 times 10 to the third at an angle. So this is a projectile at an angle. So I need an angle. And they tell me that that is 55.0 degrees. So this is going to give me my initial velocity. And that is rather large. It's 1.70 times 10 to the third. 3 is not very good, meters per second. Well, let's think about that in real terms. The only reason they gave it to us in scientific notation is because it tells us 3 sig figs, 1.70, 3 sig figs. But if you're trying to do the math on this, it's probably easier to convert that into your normal numbers that you're used to. So 10 to the third means multiply by 1,000, so the decimal is going to move to the right 3 places. So this is 1,700 meters per second. This is quite fast. They tell us about 5 times the speed of sound, so Mach 5. Neglecting air resistance, we want to find the horizontal range. So that means how far is this projectile actually going to go? We want to figure out what's delta x. So the only real assumption that's different from what you guys know about acceleration in the x and the y, and what you know about the initial velocity and the final velocity in the x direction, is the fact that if you think about this missile or whatever starting from the ground and it ends on the ground, that means that delta y is 0 meters. That's the only extra assumption you need to solve this problem. So that is my hint for part A. For part B, they ask, find the amount of time the shell is in motion. So we're looking for delta t. Well, after doing part A, you know delta x. You also should know v initial in the x direction. You also know v final in the x direction because these guys are the same. You also know acceleration in the x direction. And so you have pretty much everything you need. The only real useful equation in the x direction is delta x is vi x delta t. If you know this, you can find delta t rather easily. So that's my hint for number 34 if you're going back through this. So now let's focus on number 35, which I think was a little bit more challenging, especially part B. So in this problem, we have a place kicker must kick a football from a point 36.0 meters, which is about 40 yards. So, not the longest field goal ever, but not like the point after. So this is a decent goal. As a result of the kick, the ball must clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a speed of 20.0 meters per second at an angle of 53 degrees to the horizontal. So if you don't watch football very much, we have to think about what is going on. And crossbar, that's the field goal thing that they have to kick it through. So if this is your field, over here is your end zone. Maybe this is your end zone in here, this region of the field. And in the end zone, or at the back of the end zone, there are these uprights. And so what's happening is we have a little field goal kicker downfield. I'm getting a little artsy with my diagrams here. But then he has a football that he's trying to kick. You don't have to draw this. But he's trying to kick this so it's going to go through the uprights because that means that he makes his field goal. So they tell us The height of this field goal crossbar, they tell us that this is 3.05 meters. They also tell us that he's about 40 yards from the goal. And we don't want to deal with yards. So they were nice and converted this for us. So they told us that was 36 meters. So that's your delta x. And we know the ball has to do that much. So I want to talk about delta x, delta y. It appears that this is going to be delta x and this is going to be delta y. But if we assume that both of those are delta x and delta y, there's really nothing left for us to solve to see if the ball clears or falls short. So you have two options. You can either assume that 36.0 meters is your delta x and find delta y. So in other words, figure out, will the ball go here? Will the ball go through here, here? Will it go above the crossbar? Or will it go below, in which case he misses? So you can assume that 36.0 meters as delta x, find delta y, and see how it compares to 3.05. Alternatively, you could assume that 3.05 meters is your delta y, and figure out for that delta y, how far does it go? So in other words, when it reaches this height, does it land here? In which case it falls short. Does it land here? Does it cross here? 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 Whatever is easier for you to visualize. If you're assuming that 3.05 is your delta y, find delta x and see if it's longer than delta x, then it makes it. If it's shorter, then he misses. So I think it's easier, this is just my personal opinion, but I think it's easier for this to be your delta x and see where it goes through on the delta y, because to me that makes sense. Does it go above the bar? Does it go below? And actually that's what the answer in the back of the book deals with. So when you answer that question, part B says, does the ball approach the crossbar while still rising or while falling? So there are a couple ways that you can go about this problem. One way is to look at actually not that, because you'd have to interpret that anyway. One way is if you know that at the tallest point, so in other words, treat the tallest point as your final position, that means that v final in the y direction is 0. If you figure out how far it went for that v final, in other words, this is no longer your delta x, we want to know, does it reach its highest point here, 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 here? If it reaches the highest point before traveling 36.0 meters, then that means that the ball would be falling because it would be after the v final. So for example, if at the tallest point delta x was 12, that means that after 12 meters it reaches the highest point, but after that it must fall, so it's falling when it goes through crossbar. Alternatively, say delta x was 40 meters. That means that he kicked the ball so well that it went through the crossbar, got to the highest point at 40 meters, and then started falling. So it was rising through the crossbars. Now, some of you that are very logical know that a 40-meter field goal is not a close field goal, so it's probably going to be falling. You know, versus the point after a touchdown, he's so close that that tallest point is probably going to be after the crossbar. So this one was a little bit more challenging, and I hope these hints help you fix your homework.